This video is about the most important function in all of R, the stir function. This function is really handy, it's really useful, I use it all the time, and you can use it in all kinds of situations just to help you out to look at R objects. So the idea behind the stir function is that it's supposed to compactly display the internal structure of an R object. So STR you can think of as meaning structure. So it's a very simple diagnostic function. It's very versatile, and the idea is that you can use it as like an alternative to summary. So if you want to look at an object and see what is it and what's in it, you can use summary, which will often be very useful, but stir is another option. It's particularly well suited for compactly displaying large lists, which may contain nested lists, and its goal is to produce roughly one line of output per basic object. For example, so if you give it a simple object like a vector, it'll give you one line of output back. It'll print it to the console. And so the basic goal of stir is to answer the question, what's in this object? I'm going to start up R here, and I'm going to just give a little demonstration of how the stir function can work. So here you can apply stir to itself, and you see it's a function that takes an object. And it can take any R object. So you can apply stir to other functions. So let's say I want to know what the LM function does. So here what it gives you, it gives you the function arguments for the LM function. So here you can see it's a very brief summary. Take the first argument's a formula, the second argument's data, etc. I can look at maybe the LS function, and it gives me what are the arguments for the LS function. So if you want to look at some data, though, let's say I'm going to generate some normal random variables here. 100 of them, let's say mean 2, variant, and standard deviation 4. Now, one thing you can do is just do summary on X, and that'll give you like a 5-number summary plus the mean. So you get the mean, median, the 25th, 75th percentiles, and the min and the max. So that gives you a rough sense of kind of what the range is and how it varies. You can also call stir on X, and it'll give you a little bit more information. So it'll give you a one-line output. It tells you that X is a numeric vector. There are 100 elements. And it'll give you the first 5 numbers in this vector, so you can get a sense of kind of what the data look like. You can apply stir to other types of vectors. So here I can create like a factor variable. So this is the factor that has 40 levels, and each one is repeated 10 times. If I call stir on it, it'll give me a one-line output again. So here it tells me it's a factor. It's got 40 levels. The first 4 of them are named 1, 2, 3, and 4. So that's not particularly interesting. And then here I said the first couple of elements of this factor are all all have the label 1. So you can also call summary on a factor, and you can see that the output's a little bit different. And what this does is it gives you the number of elements in each of the 40 different levels. So that's another piece of data that's not quite as compact of output as stir gives you. So you can use stir for other types of data types. So here I can load like a data frame. Here's the air quality data set. So if I look at the air quality data set, I can use the head function to look at the first 6 rows, or I can call stir to get some different output. So here it tells me it's a data frame. It tells me that there's 153 observations, so 153 rows in this data frame of 6 variables. And then for each variable, it gives me a little output. So it tells me that the name of the first variable is ozone. It's an integer variable, and here are the first couple of observations. So you can see there's some NAs there, so that's useful to know. The second variable is called solar R, and it's also integer, and you can see that the first couple of values. So the stir output here is very useful for kind of just getting a quick examination of data that you might have in R and what the structure of different R objects is. We can take this a little bit farther. So for example, we could create a little matrix here. I'm going to put some random normals in there, and it'll be a 10 by 10 matrix. Call stir on M. See, it'll give me a little bit more information. So now it knows that it's a matrix. It'll say it's a 2-dimensional array. It's got 10 rows and 10 columns, and here are the first couple elements. So that's going to be the first column that you're seeing there. So if I just print out the first column here, you'll see that that's what it's giving me in the stir output. The last thing I'll do here is create a little list using the split function and see how stir can look at the list and give a compact summary of it. So I'm just going to take this air quality data frame and split it by the month. So here I got an air quality. I'm going to split it by the month variable. So now if I call stir on S, you'll see, oh, there's a bit of an output that flies by. You see now this is a list that contains 5 different data frames where each data frame corresponds to the data for a given month. So the data are only collected over 5 different months, so that's why there's only 5 elements. So here you can see that the month 5, which is May, has 31 observations on 6 variables, and that's a little bit of what the data look like. You can see for June here, there's 30 observations on 6 variables again, same 6 variables of course, and that's what the data look like there. And then for July, the data are here, and August and September. So you can see you can have a representation of this split list that's kind of, it's not as compact as it was before, but it's about as compact as you can make it. And stir will provide a very nice summary. You can take a quick look at the data, see if there's any problems, see if there's missing values, and get a sense of what to do next. So that's the stir function. I'll repeat again, I think it's the most useful function in all of R, and you can use it in all cases. I'd encourage you to use it anytime you have an R object and you don't know what's there.